All right, good evening and welcome to Master Talker online class. In today's video, we'll be talking about solving electronic configuration of an atom, right? So how do you write the electronic configuration of an atom? Look at what you need to do for me. Just do this, right? If you draw this, you have I have my SPDF. You know, we have done writing the electronic configuration of an atom in terms of shell. That is KLMN shell. So you can watch that in my former video, right? In the first video. So now in this one, we'll be talking about writing electronic configuration in terms of SPDF. SPDF, all right? So if you write, this is your S, P, D, and F, right? So now let me have the first one to be 1, 2, 3, 4, 5, 6, and 7. So I have, this is 1, so we have just one S, and since it is 1, it's only one, what is it called? One orbital I'm going to write. So this one is 2. I have 2S and 2P because they are 2. 2S and 2P. So the next one is 3. So I have what? 3S, 3P, and what? 3D. So the next one is what? 4S, 4P, 4D, and what? 4F. Okay, so the next one is what? 5S, okay, 5P, 5D, 5F. Okay, so we don't have the fifth one, so you stop here. So the next one is what? 6S, 6P, 6D, and then 6F. You stop here. So the next one is what? 7S, 7P, 7D, and what? 7F. So you stop here. So having this now, so you are going to be taking them from the diagonal. So I'm taking this one from here to here. Okay, this one from here, you join it to this. I'm getting only 2S. From here, you join it to this, and to this. Okay, so the next one is from here, I'll join to this point, to this point, to this point. Right? So the next one you're joining from here, you're joining to this point, and then, okay? So the next one is from here, you're joining to this point, and then to this. All right? So the next one you're joining is what? You're joining from here to this point, to this point, to this point. So the next one you're joining is from here to this point, to this point. So the next one is what? From here to this point, and finally this particular one. So which means anytime you're writing electronic configuration of an atom, so we met, first of all, you start from up to down. So we met 1S, you close. And don't forget that the highest electron S can take is what? 2. You close. You now go to the next one. We have what? 2S before 2P. 2S came like this. So I have what? 2S and what? 2P. I close for 2. And don't forget that this is 2, while this is 6. You close for 2. So you come down to the next one. After 3S, I have what? 3P. Okay. So after 2P, I have 3S before I have 3P. So I have what? 3S and what? 3P. So this is 2 and 6. All right. So I'm done like this. So I move again. After the 4S, guess who I met? I met 3D. So after 4S, too, the next person you should write is 3D10. Okay. Don't forget that the maximum electron each of them can take is the highest. This one can take 2. Add 2 to this, add 4 to this, you have 6. Add 4 to this, you have 10. Add 4 to this, you have 14. So the maximum electron S orbital can take is 2, and the maximum electron P can take is 6, and then and so on and so forth. So now after the 4D, I got after the 3D, I got 4P. So I have what? 4P before I close for 4. So the next one after 4P, I got what? 5S. So you have what? 5S. Now, after 5X, get who we saw? 4D. So, in fact, if I get to this place I know that I will not be increasing according to what I'm seeing here. So this is what 4. I've closed for 4. So if you add 1 here, you see 5s2. Then you need to do this one first, 4d10, before you do this one. Before you do what? 5p6. Are you getting it? You close. So what do you think the next one will be from the way we are saying it now? The next one is what? And you should know where D, each of them came in. Okay, D came in after 4s, and then F came in after F came in at the after 5s. Please, F came in after 5s. You should note these two things. Then you may not be able to start drawing this thing before you write electronic configuration. Just know where D and F came in. That's all. Okay, D came in immediately after 4s, and then F came in immediately after 6s. Okay, so if you just add 2 to this to know where when the other one is coming in. So now what do we have now? So once this is done, I will now enter what? Let us check before we conclude. So immediately we have 5p. Where is 5p? This is 5p. So this is 6s. After 6s, before I have what? 4f. Are you seeing it now? So immediately you have 6s, then 4f now came in. Are you getting it? So F came in with 4, but it came in immediately after 4s. So now once it has come in, then just be following your pattern. I have written my 5s. So the next thing I'm writing is what? 5d. So I have 5d, and then finally what? 6p. You close. So since they have come in, just be increasing them the way they are. So the next one I'm supposed to write is what? 7s, 5f, 5f what? 6d, and what? And 7p. You see, so this is how you should continue. So what do you think the next one will be now? 8s, 6f, 7d, and what? And 8p. So you should know where D came in, and D came in with 3, and it came in immediately after 4s. Then F came in with 4, and it came in immediately after 6s. Once you know this thing, you can now write electronic configuration of any atom at all. All right. So let us take the first question. So they said write the electronic configuration of an atom with 50 electrons. Right? So now from here, what do we do? This is very, very simple. Solution. So what do we do now? Let's go. We have that, so we have 1s2, 2s2 and 2p6, 3s2 and 3p6. Don't forget that D is not coming in here. D will come in immediately after what? 4s2, then have what? 3d10, then what? 4p6. Okay? So the next one is what? Should increase from 4. You will now enter what? 5s2, then you move to what? 4d10, then you move to what? 5p6. Don't forget that F is coming in immediately after what? 6s. So we now say 6s. We increase this one 6s. Instead of increasing this one first, F will now come in with 4. So 4f is now coming in, 2 and 14. Then after 4s coming in, we have what? Increase this one, 5d10, and then 6p6. You get that? So now add it to know if it has gotten to 50. 2 plus 2 plus this is 10. 10 plus another 10 is 20. 30. Okay? 38. 48. So we have even written more than that. 50 ends here. This is 2. So 50 ends here. So since 50 ends there, so now we can get all our quantum numbers from the last electron that we are seeing, from this last person. So what do we mean by that? You will see that what? The principal quantum number is always the coefficient of the last one you are seeing. So the principal quantum number n is equal to what? 5. The principal quantum number of this last one. We want to take the principal quantum number of this last person. Okay. In fact, we want to take the quantum numbers of this last person. So I have that what? This is 5. Are you getting that? So the next thing is what? Your azimuthal or subsidiary. You know that azimuthal is equally called subsidiary. Azimuthal quantum number is what? Is your L. How do you get azimuthal quantum number? Don't forget that azimuthal quantum number is by 0, 1, 2, 3, and it is for S, P, D, and F. So since we are talking about P here, the azimuthal quantum number here should be what? 1. Okay. So now the next thing we should do is the next thing we should do is to get our magnetic quantum number, our M. How do you get your M? You draw like this. Let us draw. And if the principal quantum number, if the azimuthal quantum number is 1, then what you are drawing will start from -1, 0, and that 1. Okay. So how many electrons do we have here? We have 2 electrons. You write it like this. You know that spin will help us. You spin up first before you start spinning down. Okay. Since the last electron stops at 0, so what does it mean? Our magnetic quantum number is 0. Are you with me? And since my spinning is spinning up, so it means that my spin quantum number is positive half, because it is spinning up. But if it is spinning down, it will give you what? Negative half. So that is how to find the quantum numbers of such electron. Now, another thing they can ask you to find is the paired and unpaired electron. The paired and unpaired electron. First of all, we need to get, from here we can get the unpaired electron. It is very obvious that the unpaired electron are what? 2 in number. So you tell them that what? Unpaired electron is equal to what? 2. Now, how do you get the paired electron? The paired, permit me to write it here. The paired electron is gotten from, now add all the total number of electrons we have. We have 50 according to what they have. But if they did not give you that, you can count it from here. You see that they are 50 in number. So how do you get it? Just say 50 minus that unpaired electron, everybody divided by 2. So what do we have now? We have 50 minus this will give you 48. 48 divided by 2 will give you what? 24. So we have 24 unpaired electrons, right? 24 unpaired electron. So is there any other thing they can ask you there? Which other thing can they ask you? Let me remember. Okay, so that is that. The unpaired electron is 24, right? So which other thing can they ask us to find? Okay, maybe as we move in with some questions, we can now find out any other thing they can ask us using that, right? Right. So let's solve the next question. Okay. So let me clean this. So the next question, as we are writing the questions, we can now be seeing what. So we don't even need this table for us to write the electronic configuration of any atom. We don't even need this table. So just know where D will come in, and know where P will come in. Sorry, and know where F will come in. And know that D is coming in with 3, and P is coming in with what? 4. And they are coming in, D is coming in immediately after what? After 4s. Okay, and then add 2 to that 4, then you now know that F is coming in immediately after 6s. Right. So let us now solve some questions concerning that. So the first question we're going to look at said question number, okay, they said the last electron, they said question number 1 example, they said the last electron in an atom, is described by the quantum numbers. Okay, they describe it by the quantum numbers n is equal to 3, comma, L is equal to 1, M is equal to minus 1, and S is equal to plus half, right? So this is very, very simple to get. So what do we do? Solution. This is very simple. So now we always know that what? That the first one, the principal quantum number n is always the coefficient. So I have my 3. Okay. My L is called the azimuthal quantum number or the spin quantum number. Don't forget that azimuthal quantum number ranges from 0, 1, 2, 3 for S, P, D, and F. So since I'm having that it is 1, so it means that it is for P. So this is 3P. Okay. So the next thing we need to know is now the electron it has. So you now draw. And I told you that if it is P, P is 1. So if it is P, you have to now range it from minus 1, 0, and 1. But if it is 2, you range it from what? Minus 2, minus 1, 0, 1, and 2. Okay? If it is for this one, P, that is 1, it will be what? Minus 1, 0, and 1. But if it is this one, it will be minus 2, minus 1, 0, 1, and 2. But if it is this one, it will be minus 3, comma, minus 2, minus 1, 0, 1, 2, 3. Okay? So that is the number of orbitals or it has. Now, let us now spin it. Okay? Now, they say that my last spin stops at where? At minus 1. So my last spin will stop at this minus 1. And the thing spins up because I have positive half. So I'll just spin up and stop. Okay? So because the first one I'm hitting is that minus 1 and I spin up. So which means the only electron we have here in the in this last orbital is what? Just 1. Okay? Since we have that, then I say we should describe the okay, the last atom is given by this. Oh, then I say find the atomic number. So this question is not complete. It's a find the atomic number of the atom. Okay, sorry, the question is not complete. So we should find the atomic number. So how do you find the atomic number of this atom? Now they say that the last electron is this. So which means let's continue the way we normally write electronic configuration. So let's write that 1s2, it must be filled, comma, 2s2 and 2p6. Now 3s2. Now the last person is what? 3 and p will be what? This is the last person. So therefore the atomic number will now be equal to what? Add them. The number of electrons is the same thing as the atomic number. So 2 plus what? 2 plus what? 6 plus what? 2 plus what? 1. So if you add them together, you are having 10, 13. So 13. So the atomic number of this atom is 13. All right? So let's move to the next question. See, this is very, very simple. Very, very simple. Okay. So let's move to the next one. Okay, the next one here said question number 50. It said the last electron in an atom is described by the quantum number. They gave us that n is 3, comma, L is 1, comma, M is minus 1, comma, and our S is equal to minus half. All right. So now, if you look at this, you have to know that solution. Okay, sorry. The question said, then find the atomic number. Okay, find the atomic number. Okay, solution. So what do we have? If we have that the principal quantum number is 3, that's the coefficient 3. Sorry. Sorry. So I have that the principal quantum number is 3, that's the coefficient 3. But the azimuthal quantum number or the subsidiary quantum number is 1. And I told you that what? Azimuthal quantum number ranges from 0, 1, 2, and 3. Okay, for what? For S, P, D, and F. So since it is 1, is for P. So this is just 3P. And I told you again, for the magnetic quantum number, that if it is at P, P is 1. So the magnetic quantum number will be what? Minus 1, 0, and 1. Very simple. So you draw your shell, you draw your orbitals, you share it into what? -1, 0, and 1. And they say that the last electron stopped at -1, but it was spin down because this is negative, so it will spin down. So according to Pauli's theorem, he said that we have to spin up first before we now talk of spinning down. So we are stopping here because they say that the spinning down stopped at -1 of the magnetic quantum number. So now, how many electrons do we have? 1, 2, 3, 4. So this is 3p4. Okay, very simple. So how do you write the electronic configuration of this atom? We start again. 1s2, 2s2, 2p6. You close. Then 3s2. Then they say that the last electron is this, so and it is coming with what? 3p4. Okay, so therefore the atomic number, very simple, atomic number will now be equal to what? 2 plus 2, 2 plus 2 plus 6 plus 2 plus 4. So if you add them, you have, this is 10, 12, 16. I have 16. Okay, very, very simple. 16 is the atomic number. So we move, right? Okay, so let's take the next question. All right, the next question here said, okay, question number 22. Okay, they said elements with sorry sorry okay, they said which element possesses the electronic configuration of 1s2, 2s2, 2p6, 3s2, 3p6, 4s1, 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 and 3d10. Okay, rather than 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, and 3d 3d9. Okay, now normally this is how the electronic configuration is supposed to be. Okay, this is how the electronic configuration is supposed to be, but they say which element possesses this. Just count it for me. If you count it, you see 2 plus 2, 4. Let's get the atomic number. 2 plus 2, 4. 4 plus 6 is 10. 10 plus another 10 is what? 20. 20 plus 9 is 29. So which atom has 29 electrons? I think it's copper. So copper is an atom that has 29 electrons. So that is what I think is the result. So the next question. So next question said here, elements with the atomic number this belong to. Okay, they said an element with an element with atomic number of 25 belongs belongs to belongs to belongs to dash block of element. Okay, they say while the while element with atomic number of 17 belong to dash block. Okay, so what do we do? Okay, so what do we do? We write the electronic configuration of such um, atom. All right, so let's do that. Solution. For the first one, they say that it has 25 electrons. So let us write the electronic configuration of an atom with 25 electrons. So I have what? 1s2, 2s2, 2p6, 3s2, 3p6, 4s2. Let's count 25. So from here to here is 10. From here to here is 20. So, and you know that D comes immediately after 4s. So you have what? 3d5. Why is it 5? Because it's already 20. From here to here is 10, and from here to here is another 10, so 25. So it belongs to what? To the D block element. So this first one belongs to the D block element. The D block element. Why? Because it ends in D, so it's a D block element. Okay, so let's check the next one. 17 is 1s2, 2s2, 2p6. Here is 10, so I have 3s2, 12. So I have what? 3p5. Okay, to make it 17. So this one belongs to what? The P block element. It belongs to the P block element. See, very simple. So we move to the next one, and the next one said the last shell of a given element has 4d8. Full stop. Then I said find the number of the paired and the unpaired electron. Find the number of the paired and unpaired electron. Okay, find number of the paired and the unpaired electron. This is very simple solution. So what do we do? First of all, let us get all the quantum numbers of this. The coefficient 4 means that the principal quantum number is 4. Now D, for the azimuthal quantum number, I told you it ranges from 0, 1, 2, 3 for S, P, D, and F. So what does it mean? That the azimuthal quantum number for D is 2. Okay, so now for the magnetic quantum number, we need to draw it. Let us draw it first. I told you that this one is just 0. Why this one is what? From -1, 0, and 1. Why this one is what? -2, -1, 0, 1, and 2. So we have to share this to what? -2, -1, 0, 1, and 2. Okay, so let us share our electrons that we have. Let's go. You have to spin up before spinning down. We spin up 1, spin up 2, spin up 3, spin up 4, spin up 5 before we spin down 6, 7, and 8. So what does it mean? Since our last electron stopped at 0, so it means that what? Our MO, the magnetic quantum number, is 0, and it stopped with a spinning down. So it means that what the spin quantum number is -12. because it stopped at spinning down. So now, if you look at this, you see that all these ones are paired. The only one that is not paired are 2. So we have what? For the unpaired electron, unpaired electron is just what? 2. So how do you get the paired electron? First of all, let us write the electronic configuration of this atom. So we have what? 1s2, 2s2, 2p6, 3s2, 3p6, then 4s2, 3d10, and what? 4p6. Is it not true? So we now continue again. Increase this one. I have what? 5s2. Increase this one. I have what? 4d. It's supposed to be 4d10, but they said that that electron stopped at where? 4d8. Okay, so now let us add the atomic. Let us find the atomic number. The atomic number of that electron is now what? Of that atom is now what? From here to here is 10. From here to here is another 10, which is 20, 30. This 2 is 40, 46. So I have that it is what? 46. So it has 46 electron. And we have that the number of unpaired electron is 2. So what about the paired electron? So the number of paired electron is simply the total number, which is 46, minus the number of unpaired electron, then divided by 2. So what do you have? 44 divided by 2, which is what? 22. So we have 22 paired electron and 2 unpaired electron. So you see, this thing is very, very simple. It's very, very simple. Okay? So let's move to the next one. So for the next one, they said they say the block the block of the element with atomic number of 10 and 11 are dash and dash respectively. Solution: very, very simple. Let us write electronic configuration of an atom with 10 electron. So if it has 10 electron, the electronic configuration will be 1s2, 2s2, and 2p6. So this is 10 complete. So it is what? A p block element. This is for p block element. So let's go for 11. 11 electron will be what? 1s2, 2s2, 2p6, then what? 3s1 to make it 11. So it ends in s. So it's what? An s block element. Okay? I can clean. So the next question here said the quantum number that defines the shape of the orbitals okay, the orbital occupied by the electron is okay. What type of quantum number describes the shape of the orbitals? I think is Azimuthal quantum number. Can I remember? Number what is it? Number 23. Azimuthal quantum number, correct. So Azimuthal quantum number shows the shape of the orbital. And don't forget that S has a spherical shape, P has a dumbbell shape, and D has a double dumbbell shape, while F, the shape is complicated. We don't know, the shape is complicated. All right? Okay. But the quantum number that shows the shape of an orbital is called the Azimuthal quantum number. Okay, so the next one, they said two electrons occupying the same orbital has different dash. Do they have different principal quantum number, or different azimuthal quantum number, or different subsidiary quantum number, or different spin quantum number? Now, uh, if they occupy the same orbital, they will have everything as the same except the spin quantum number. Okay, why? Because the spin quantum number will show you different shapes. In fact, it will show you different shapes of that orbital, because we have that for p orbital, we have px, py, and pz for the spin. All right, so the answer is what? The spin quantum number. It is the spin quantum number that will show you the that show you that's the only thing they have differently if they occupy the same orbital. You know, they are occupying the same orbital as p, but they will have different orbitals like p suborbitals, okay, like px, py, and pz. All right, so, and it is the work of the spin quantum number. So the now said the next one, the ground state electronic configuration of carbon atom has dash paired, okay, dash pairs and unpaired electron. All right, solution. You know that carbon is number 12. If you can sing it: hydrogen, helium, lithium, beryllium, boron, carbon. Okay, carbon is 6. Oh, it has 6 electrons. Okay, so since it has 6 electrons, so let us do that. Carbon with 6 electrons. So if you write the electronic configuration, you have 1s2, 2s2, and 2p6. 2p4. All right, then from here, this is the last electron. From the last electron, we can know the paired and unpaired electron. But let me do extra work by telling you that the principal quantum number is the coefficient, which is what? 2. Okay, the azimuthal quantum number L is gotten from 0, 1, 2, and 3, which is for S, P, D, F. And since it is P, it is 1. Okay, so the next one is the magnetic quantum number. You know that if it is 1, it will be from -1, 0, and 1. So let us draw it first. -1, 0, and 1. So, and the last electron here is 4. So let us share it. Spin up first. 1, 2, 3. So before we spin down, So we stopped at -1. So the magnetic quantum number will be -1. And since we spin down, so this the spin quantum number will be -half. Okay. From here, we can easily see that the unpaired electron here is what? Is 2. So carbon has 2 unpaired electrons. So for unpaired electron, let me write here: unpaired electron is equal to what? 2. Now for the paired electron, we have the total number of 6 electrons. So we say 6 electron minus the unpaired electron, then divided by 2. So you have what? 4 divided by 2, which is what? 2. So which means carbon has 2 unpaired electrons and 2 paired electrons. Okay, so very, very simple question. All right, so the next thing, okay, so the next question, we move. The next question here said it said the number of unpaired unpaired electrons in the element with atomic number of 47 is dash. Okay, is dash. So we need to calculate the number of the unpaired electron. Before you calculate the number of the unpaired electron, you have to write the electronic configuration first. So I have 1s2, 2s2, 2p6. You close. You increase this one by 3s2. You increase this one by 3p6. D is not coming here. So you now increase this one by what? 4s2. And not forget that D will enter immediately 4s. So I have that what? And it's entering with 3. So 3d10. Then increase the last one here to be what? 4p6. So we start increasing again. We close here. We start increasing again. 5s2, 4d10. Please let me check if I have exceeded the 47. From here to here is 10. And from here to here is another 10, 20. Here is 30. Okay, 36, 38, 48. So here should be 9. So here should be what? 9 to make it 47. So the last thing I'm having here is what? 4d9. So from here, let me get extra thing before getting the paired and unpaired electron. So from here, the coefficient shows that what? That the principal quantum number is 4. Okay, then the azimuthal quantum number is gotten from 0, 1, 2, and 3 for S, P, D, and F. So since it ends in P and P is 2, we have 2. And don't forget to get the magnetic and the spin quantum number. That 2 will start from -2, -1, 0, 1, and 2. So we draw it. We have -2, -1, 0, 1, and 2. Okay, and the electron we are sharing for them is 9. So we spin up first before spinning down. Spin up 1, 2, 3, 4, 5. Before we spin down 6, 7, 8, 9. Okay, we stopped here. We stopped at 1. Since we stopped at 1, it shows that the magnetic quantum number is 1. Okay, so now the next thing we are getting is the spin quantum number. And the spin quantum number, since it ended with spinning down, the spin quantum number will be -half. These things are very, very simple. So what else do we need to do? We now see that the number of unpaired electron is just 1. So the number of unpaired electron is 1. So we have that the number of the unpaired electron is just 1. So how do we calculate the number of the paired electron? The number of the paired electron, unpaired, let me write it here. Unpaired electron is equal to 1. Then for the paired electron, we have what? The total number is here, 47 minus that one, then divided by 2, which is what? 46 divided by 2, which is what? 23. So it has 23 paired electron and 1 unpaired electron, right? We keep moving. Number 15. Okay. So the next question said, what are the atomic orbitals that can be found in the second energy level? That can be found in the second energy level of electron. Okay, now very simple. Now for the solution, if you're writing electronic configuration, you will see that the first energy level is just 1s. So the orbital that is found in the first energy level is just 1s. That is s. Then for the second energy level is what? 2s and what? 2p. So therefore, the orbitals that can be found in the second energy level is what? S and P orbitals. Very, very simple. These people don't have question to ask. Very, very simple questions. All right. So let's move to the next one. So the next one here said, it said the last shell. Okay, we have done paired and unpaired electron. So let me just leave this one and look for another thing entirely. We have done paired and unpaired electron. Okay. So look at this one. They said the orbital, the orbital de designated uh the orbital designation, okay, the orbital designation, okay, of the last electron, okay, the last shell of a given element is 4d6, comma, then I say find the number of electron in the outermost, comma, okay, find the number of electrons in the outermost, comma, then find the anti-penultimate and the penultimate. Okay, solution. Now, to find they said we should find the outermost electron. Okay, to find the outermost electron, okay, find the number of electrons in the outermost shell. Okay, first of all, let us get this. They're telling us about shell and not orbital. So let us now get the electronic configuration in terms of orbital so that we can know the total number of atomic number. And we will now know the atomic number. Then from the atomic number or the total number of electron, they will now write that electron in terms of shell. Then we can now know the number of electron in the outermost shell. So first of all, we have what? 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d. Supposed to be 10, but they said it stopped at 6. So let us count them. How many electrons? So I have from here to here is 10, and from here to here is 10, which is 20, 26. So it has 26 electrons. So since it has 26 electrons, so let us do it in terms of shell. It will now be 2, 8, 8, 8, how many? This is, what do we have? This is 10, 18, 18. This is 10, 18, 26, right? 26. Is that? Let me check. Okay. The outermost shell is 2. That is the orbital with the highest quantum number. Oh, okay. So another way we can get it. So this is not correct. So another way we can get it, sorry. So they said the outermost shell. The outermost shell is simply the same thing as the orbitals with the highest quantum number. The orbitals with the highest quantum number. So let us check. The quantum number here is 1, 2, 2, 3, 3, 4, 3. So the highest quantum number here is what? Is 4. And the electron there is what? 2 electrons. So therefore, the outermost electron, the outermost electron is simply what? 2. Okay. So the next thing we need to get is the anti-penultimate shell and the penultimate shell. Anti-penultimate shell and the penultimate shell. Okay. So the anti-penultimate shell is all the 3. Okay. Why the penultimate shell is now for the 4. So I have the anti-penultimate shell, the anti-penultimate shell is what? We have 3s2, 3p6, and 3d10. Okay. So what do we have? This is 2 plus 6 plus 10, which is what? 18. So now the penultimate shell are now all the 4. So penultimate shell. Sorry, this thing is very wrong. This is very wrong. They said we should have that is stopped at 4D. Why did I stop at 3D? Sorry, this is very, very wrong. So this is 4s2, 3d10, and 4p6. So the next one we should now have is now 5s2. You know that then 4d6. So this is now very, very correct, please. This is now very, very correct. So the total number of electrons here is what? From here to here is 10 and 10, 20, 30, 36, 42, 44. So I have 44 electrons. So it has 44 electrons. So let me check by KLM shell and see what happened. This is 2, 8, 8, let me say 8, there should be 18 somewhere, but let me just use 8, 8, what do we have now? 8 plus 8, 16. 16 plus 16 is 32. 32 plus 2 is 34. 34 plus 8 is 42. 42 plus 2 is 44. So watch that now. We have 8 plus 8 is 16. 16 plus 16 is 32. 32 plus 8 is 40. 40 plus this is 44. You now see that is now corresponding. So the outermost shell is what? 2 electrons. Or from your electronic configuration, the outermost shell is gotten from the orbital with the highest principal quantum number. So the principal quantum number, the highest is 5. Okay, and it is X, which has 2. So we have what? 2 in the outermost shell. You can get it from here, or you can get it from KLMN shell. Okay. Now, then the penultimate is gotten from all the 3s. So let's go. We have 3s2, 3p6, and 3d10, and the total is 18. So, but the penultimate are now all the 4s. The penultimate shell is now what? The first 4 I'm seeing is what? 4s2, 4p6, and what? 4d10. So I'm having 2 plus 6 plus 10, which is what? 18. So we have 18 penultimate shell and equally 18 sorry, is it 4d10? 4d6. What am I saying? 4d6. So we have 6 plus 6, 12, plus 2, 14. 14. Okay, we have 14 electrons, 14 penultimate, and 18 anti-penultimate shell. Right? So that is that. So the next question. Then the next thing they can ask you is okay. Let me check if it is being asked here. Okay. Okay. From the same question, please. From the same question that has 4d6, they say we should calculate the paired, okay, the paired and the unpaired electron. Calculate the paired and the unpaired electron. Okay. And we should equally calculate the magnetic moment. The paired and the unpaired electron. Then we should calculate the magnetic moment. Then what type of block, the period, the atomic number, everything. Okay, so here we still have the 4d8, 4d6, and we need to calculate the paired and the unpaired electron. So let us still write the electronic configuration again. 1s2, 2s2, 2p6, okay, 3s2, 3p6, 4s2, 3d10, 4p6, then 5s2, 4d6. All right. Now from here, how many electrons does it have? This is atomic number is the number of electrons. So I have 10 plus 10, 20, 30, 42, 44. So the atomic number is 44. The atomic number is 44. All right. So from here, we can calculate from the last electron here, we can calculate all the quantum numbers. So the principal quantum number is 4. The magnetic quantum, the azimuthal quantum number is 0, 1, 2, 3, 4, S, P, D, and F. So it is 2. And I told you that if it is 2, I'll have from -2, -1, 0, 1, and 2. So we're having it -2, -1, 0, 1, and 2. So I have this. All right. So let us share the last electron there, 6. If we share it, we spin up first. 1, 2, 3, 4, 5. Then we spin down 6. So since it stopped at -2, it means that what? That our magnetic quantum number is -2. And the spin quantum number, since it stopped with spinning down, the spin quantum number is -half. Okay? So from here, we will now know the number of the paired and the unpaired electron. The number of the paired and the unpaired electron. From here, the unpaired electron first. The unpaired electron is simply, how many are they? 1, 2, 3, 4. They are 4 in number. Then for the paired electron, the paired electron is simply the total number we have, which is what? 44. 44 minus that paired electron 4, then divided by 2, which is what? 40 by 2, which is what? 20. So we have 20 unpaired electron. All right. So the next thing we will calculate is the magnetic moment. In fact, what type of block is it? It is in is a deep block element. Okay, it's a deep block element, and the period is gotten from the number of shells. That is 1, 2, 3, 4, 5 shells. Okay, you see the way my comma is: first comma, 1 shell, the second shell, third one, fourth one, fifth one. So the period is 5. Okay, and it's a deep block element. All right, and the atomic number is 44. So the next thing is the magnetic moment. The magnetic moment, let me clean here. It has a formula. The magnetic moment is gotten by magnetic moment. Magnetic moment. Okay, the magnetic moment is gotten from a formula that said n in bracket of 2n plus 1. Okay, it's just the square root of what? N in bracket of 2n plus 1. Please don't forget this formula. Or you say the square root of 2n squared plus n. Anyone you like. Some people use by clearing bracket, they use 2n squared plus n. Some people use this one. You will still get the same answer. And what is your n? Please note where your n is equal to the number of paired electron. Please, your n here, is it number of paired electron or the principal quantum number? Yes, your n is the principal quantum number. Yes, please don't forget. Or the number of unpaired electron. Your n here, please, is the number of unpaired electron, because I can remember that magnetic is gotten from unpaired electron. Please, the N here is not this. Please, the N that I'm talking about, this formula, is not the principal quantum number, but the number of the unpaired electron. Unpaired electron. Right? The number of the unpaired electron. So therefore, my magnetic moment is equal to the square root of what? 2 in bracket of 4 squared plus 4. So we have the square root of 2 squared is 16. 16 times 2 is 32. 32 plus 4 will give you 36. And square root of 36 is what? Is 6. So the magnetic moment there is what? Is 6 Bohr. Is written in Bohr magnetons. Bohr magnetons. So this is 6, but you have to write it to 6 Bohrs, B-O-R-H, yes, or B-O-H-R, yes, B-O-H, Bohr magnetons. Magnetons. Okay, that is the SI unit of magnetic moment. It is measured in 6. There is no space here to write it, so it is what? 6 Bohr magnetons. All right, so that is that. So thank you very much for watching. Please don't forget to like, share, and subscribe. God bless you. Bye bye.